Hi friends, in this video we will see maxima and minima of derivative concept. So here I am not going to explain the mathematical equation. I will explain the concept and the procedure to find the maxima and minima and solve some gate questions. Right? So first we must know what is maxima or minima. Right? Let us take a function f of x. Right? Let that function be represented like this. Fine. So here you see, if we see this function f of x, we can say at this point the value is maximum, right? At this point the value is minimum. Here the value is maximum. See, this point is max, this point is maximum point, this point is a point of maximum, right? Here it is minimum, here it is minimum, right? So let us assume it is going like this. Here it is minimum. Right, so this point is a point of maximum point of the function, right? This is also maximum, right? Okay, so this is called local maximum, right? So this is called local maximum, this is called local maximum. So at this point it is maximum, nearer to that point it is maximum. So for whole function I can say this is the maximum value of this function and this is the minimum value of this function. So this point will be called global maximum, this point is called global minimum, right? This is local minimum. Global minimum is the one which is the least or the minimum among the all the minimum of the function. Similarly, global maximum is the maximum value among the all the maximum. So it is global max, it is a global minimum, it is a local minimum, right? It is local minimum, it is a global minimum. At this point it is a local minimum. So that is the thing we must know. So by seeing the function itself we can say what is the maximum value and what is the minimum value. Okay, but mathematically how can we prove that? Let us take this function, right? So we know the maximum is this point, right? Let us assume this is x, this is f of x, right? And the maximum is this one. Let us assume the maximum value occurs at point P. So when x is equal to P, what is the value of f of x? That is called the maximum value. So this value is known as f of P. Fine. So y-axis is f of x, this point is f of P. So this is a point of, this is a point where the function gets maximum. So the function f of x is maximum at x is equal to P. The maximum value, the value of the maxima, the value of maxima is f of P. Yes or no? What is the value of f of x at P? That is called maxima value. Okay, this by seeing this function plot we can say, but mathematically how can we prove? You see that at this point, you see at this point the slope is 0 because there is no change. Slope is equal to 0, that is f dash of x is equal to 0 because at this point there is no change. What is differentiation? Differentiation of no change, that is differentiation of constant is 0. Differentiation gives slope. So at point P, f dash of x is equal to 0. F dash of is nothing but differentiation of f of x. Differentiation gives slope. So at point P, f dash of x 0. So you see what is happening before point P. Before at point P, f dash of x is 0. Before point P, what is happening? Before point P, the slope is increasing. It is coming like this. It is increasing. So before point P, f dash of x is greater than 0. That is increasing. After point P, f dash of x is decreasing. You see, it is f dash of x. The slope is getting reduced. The slope is going negative side. So slope is less than 0. So see, from this we can see let us take our point f of p, right? Because we have at point p, at point x is equal to p, f dash of x0. So at f of, before that point, the slope is increasing. After that point, the slope gets decreased. So if it happens, you see the point is a maximum. So this indicates P is a location of maximum, right? So a point is called a maximum point, right? Provided the value of the function before that should have a positive slope. After that point, the value of the function should be having negative slope. So then only it is called maximum point, right? Point of maximum. Okay, similarly we see for negative value. You see, take this diagram. This is what minimum point. By seeing this itself, we can say it is a minimum point. Again, at this point also, let us see it is b, it is x, it is f of x. Right, at this point the slope is 0, so f dash of x0, because it won't change. So x doesn't change here, so at this point f dash of x0, f of x doesn't change, so f dash of x0. So before that we, at x is equal to v, f dash of x0, that is f dash of v is equal to 0. Before v, you see f dash of is getting reduced, it is having negative slope, so f dash of x is having slope is negative, that is slope is negative. Fine. Okay, after v, f dash of x is having positive slope. You see, after v it is going sorry, so positive slope. So we know by seeing this itself we can come to a conclusion that v is a minimum point. So when we have a point v where there is a minimum, so f dash of v is equal to 0. So before this point, if slope is negative, that is f dash of x is less than 0. After this point, if f dash of x is greater than 0, then v is known as location of minimum, and the minimum value is f of v, and minimum value is f of v. Are you understanding? So what we have to do in order to find a particular function is minima, or to find a maximum or minimum value, first what we have to do, they will give f of x. Fine. Let me explain the procedure now. Right? What is the procedure? In the problem, they will give f of x. Right? So first thing we have to find is where the slope is 0. So we have to find the f dash of x. Given data is f of x. Find f dash of x. Right? From this f dash of x, third one, equate f dash of x is equal to 0 and find x value. X value. This x is nothing but, it may be either, this is the value where the function gets 0, that is slope is 0. So this gives the value of the location of f of x where it gets 0, where its value is 0, right? So substitute, let us assume that x is equal to TRB. Let us assume that point is C, right? So we have to substitute this value, and what you have to find, fourth one, you find one f dash of something. Let us assume k, where k is less than C. Fine. And check whether it is positive or negative. Similarly, you take some other value L, where L is greater than C, right? And find that value. Find, you choose any K or L, right? So if f dash of K is positive and f dash of L is negative, what is the conclusion? We know that f dash of x is equal to 0. So f dash of x is equal to 0, where x is equal to C. When some value k which is less than c means this side, this has positive slope. So here f dash of x equal to k, right? Which is having positive slope. L is greater than c, so I take some other value. L is greater than c, so this is L, where I substitute f dash of x is equal to L. If it is greater, it is having negative value. So before that the slope is positive f dash for this value. After that the slope is negative. Just now only we know this is a 0 point. Before that the slope is positive means it is coming up. After that the slope is negative means it is going down. So this implies C is a maxima point, right? And maximum value and the value of maxima is what? F of C. F of C gives value of maxima. Similarly, suppose this is step number, okay, this is step number 5. Suppose if f dash of k becomes negative, this one becomes negative, this one becomes positive, means what happens? Here we have x is equal to c, f dash of x is equal to 0, that is x is z. Before that the slope is negative, that is f dash of x is equal to k is negative. I change the condition. Suppose if f dash of x is equal to L is positive, where k is less than c and L is greater than c, right? So here what is the meaning of c? At this point c, before that the slope is negative. Slope is negative means it is coming down. After that the slope is getting, after c the L must be at least point not one must be point not one will be greater than c. So after that point the slope is getting increased. So my point c is what you call minima here. So this gives the location of minima. So the location of minima, this gives the location of minima is x is equal to c and the minimum value is f of c. Right? I hope you understand the concept. Let me give it one example. Let us take f of x is given as x squared minus 2x plus 2. Right? First what I have to do, as per step 1, I have to find where slope is 0. To find slope 0, first I have to find the differentiation. So f dash of x is equal to 2x minus 2. Then I have to find what is the location. So the slope is 0. So 2x minus 2. This is slope. Slope is 0 means 2x minus 2 equal to 0. This implies x is equal to 1. So at x is equal to 1, at x is equal to 1, f dash of x is 0. You substitute x is equal to 1, x dash of x is equal to 0. So I consider this x is equal to 1 is c. So c is 1. Because we know, right? So what I need to do, I told choose some value which is lesser than c and some value greater than c and find slope. So let me take some value less than c. Let me take 0.9. C is 1. So I find what is the slope. So what is the slope? F dash of x. So f dash of 0.9. What is the slope at before c is equal to 1? At c is equal to 1, the slope is 0. Before c is equal to 1, that is 0.9. What is happening? It is 1.8 minus 2. That is minus 0.2. This indicates negative slope because it is negative. So before C, the slope is negative. So let me take one value after C, 1.1. So f dash of 1.1. So substitute in f dash of x. F dash of x is 2 into 1.1, 2.2 minus 2. This is what my f dash of x, right? So there I substitute f dash 0.9, x is equal to 1. So it is positive slope. So you see at x is equal to 1 or c is x is equal to c or c is equal to 1. At x is equal to 1, slope is negative. At 0.9 the slope is 0. That is f dash of x 0. At f dash x is equal to 0.9 the slope is negative. 0.9 means it will be left hand side. It is 1. 0.9 means left hand side. So here the slope is negative slope f dash of x. After x is equal to 1, that is 1.1, the slope becomes positive. So it is going like this. F dash of x positive. So x is equal to 1 is a minimum point. Therefore, from this we understand x is equal to 1 is a location of minima. What is the minimum value of minima? Value of minima is given by f of 1, right? What is the value of the function at the minimum location? So that is f of 1. What is f of x is given? F of x is given by x squared minus 2x plus 2. So what is f of 1? 1 is a minimum location. Minimum value is 1 minus 2 plus 2, that is equal to 1. And minima is 1. And the value of minima is 1. So this is the way we have to find maxima and minima. Right? I hope it is very simple for you to understand. So simple procedure, right? This is the way we can work. So this is based on first derivative, right? We can find maxima and minima based on second derivative also. Let us see the example, right? Maxima and minima based on second derivative. Right, in problem we will use this only. Let us see why it is. What is the reason? Okay, let us take as usual. This is this point. What is this? This point is a location of maxima. Yes or no? Because this is a maxima point. By seeing this, we can say here slope negative. Here slope positive. Here slope is negative. This is x. This is f of x. Right? Is the maximum value of x. So how can we use second derivative to find the answer? See, by taking first derivative, what we find by taking f dash of x, right? We will find where the slope is 0, right? By taking the first derivative, let us assume we find here only the slope is 0 after first derivative, right? If you take second derivative, what will happen? If you take second derivative, what will happen is, right? So derivative of this one. Okay, if you take second derivative, you see after this point, the slope is negative. Yes or no? After this C, after this point, the slope is negative. So what this will do? Second derivative will give negative slope. Right? So this is what. Before this point C, the slope is positive. So if you take derivative, it will give positive slope because derivative gives slope. Right or no? Right? So you see totally it has positive slope. Sorry, totally it has negative slope because total slope is negative. So what we are concluding from this, if the function f of x is given, take f dash of x and take f double dash of x. If f double dash of x is negative at if from this you find x value where slope is 0, right? Substitute that x here, x is equal to c, right? If f dash of c is negative, then it is maxima point, right or no? Because you see it is a point of maxima. So as usual we do, you take a first derivative and find the slope. At what point the slope is 0, substitute that point in the second derivative. At this point, if the second derivative gives negative value, then it indicates it is a maximum. Suppose, let us see another an example. Right here, take this. This is point of minima. Here you see this is f of x, this is x. Then you find f dash of x and find the location of zero slope. Let us assume this is the location of zero slope. This is C, so this is C. Right? Now substitute f double dash of x. You find f double dash of x, and what you have to do is find the f double dash of x and substitute f double. Substitute x is equal to c. You see at this point the slope is 0. After that, after c, the slope is increasing, so it is going like this. F double dash of c will give slope like this, right? Before that, the slope is decreasing. Before c, you see the slope is decreasing, so it will be coming like this. So it is totally, ultimately it is an increasing slope or positive slope. Fine. So from this we can understand, if f double dash of x is greater than 0 or positive, then it is a maxima. Fine. So sorry, it is a minima. You see, it is a minima point. This is minima point, so it is a minima. So minimum point means f double dash of x must be greater than 0. Maxima point means f double dash of x where x is equal to c is less than 0 or negative. Fine. So this is the way we can solve the problem, right? So, and a few more things I want to emphasize here. You see, let us take some example, different example. F of x is equal to e power x, right? So this curve will be like this. This is x, this is e power x. At f dash of x is e power x only. Then to find zero slope, what we have to do? We have to make f dash of x is equal to 0. That is e power x is equal to 0. This won't happen. It never happens, right? When x is 0, it is 1 only, right? So e power x doesn't have 0. At minus infinity only it will become 0. Therefore, it has neither e power x neither has maxima neither maxima or minima. Fine. So that is one more important point. Then another thing we have to take is you take log x, or f of x is equal to log x, right? So in order to find where the slope gets minimum 0, we have to take f dash of x. F dash of x will never become 0. It will become 0 at only infinity. So f dash of x, if this implies log x has neither maxima nor minima, because I cannot find the location, right? It will never become 0, right? So I cannot find the location of the maxima or minima. So I cannot find the value of the maxima or minima also. So these two functions are examples for a function which has neither maxima nor minima. Okay. So let me give one maxima and minima value problem based on the second derivative. Let us assume f of x is equal to x cubed minus 3x. First, what we have to do? We have to take first derivative. right? Why? We have to find the slope. First derivative will give the slope, so it is 3x squared minus 3. Next I have to find the location of the zero slope. What you have to do? We have to make f dash of x is equal to 0. So 3x squared minus 3 is 0. This means x squared minus 1 is equal to 0. This implies x is equal to plus or minus 1. Next, what we have to do? We have to find the f double dash of x, second derivative. So it will become 6x, right? So we have two values of x. X is equal to plus 1, x is equal to minus 1. Substitute x is equal to plus 1 here. F double dash of 1, that will give 6. F double dash of minus 1 will give minus 6. See this double dash, that is the slope, f dash or f double dash, all the things will give, derivative will give slope. So second derivative is positive, that is slope is greater than 0, positive. Positive slope. Positive slope means we know it is minima. Right? Similarly, f double dash of 1 minus 1, the minus 1 gives slope which is less than 0. Negative slope means it is maxima. So x is equal to, this indicates x is equal to plus 1 is a point of minima. X is equal to minus 1 is a point of maximum. Fine. So what is the value of the minima and maxima? We have to substitute this and find the location value. We know f of x is equal to x cube minus 3x. So value of maxima, or first minima, value of minima occurs at x is equal to plus 1. So 1 minus 3, that is equal to minus 2. Right? It is a value of minima or local minima. Similarly, if x is equal to minus 1 gives maxima. So minus 1 cube minus 3 into minus 1, that is equal to 2. So it is a local maxima. Right? So in this way we can understand what is minima and maxima. I hope I have explained clearly. If you have any doubt, please ask me in comment section. I will clarify. Thank you.